All right, so state of matter. Are you seeing the screen clearly?
Yes.
Okay.
Yes, sir. Yes, sir.
All right, so of course, the first thing, what is matter? Now, of course, in terms of the first pointer, it is saying that an object which takes up space and have mass, basically, those are what you actually call matter. So right away, you look in your environment. I'm sure that you're seeing a lot of things that take up space, and of course, they have a particular shape, they have a particular mass or a particular volume. So those are things that basically we actually call matter. And once you look around you, basically you will say that everything basically will actually fall under this category. So everything in your environment, and that of course mean your surrounding, is made up of matter. Now the image that you're seeing now, the third pointer is referring to it, where it is saying a bottle water is made up of matter. So right away we're now gonna actually start to deviate to the different states of matter, because by now persons should at least remember that we actually have three main state of matter, and that is solid, liquid, and gas. Those are what would have been exposed from primary school through up to grade 9. But for your information, there's a fourth state of matter which we will actually look at during this morning's class. The last pointer, all humans are made up of matter, and that is a fact, because going back to the first two pointers, where would said that matters are basically objects that they have mass and they take up space. So linking that to the final pointer there, where they are saying that all humans are made up of matter, and that is simply because at the internal aspect of our body, inside of our body, we have different organs, or we have different body parts, and those body parts basically take up space. They basically have a certain amount of mass or a certain amount of volume in terms of size. Hence, then you would actually said that yes, actually, he made up of those different objects or those different things. Now, the states of matter, these are the physical forms which matter take in different environment. So basically what they're saying is that what we call matter, the different state of matter, that is why they call them different state of matter. And that is simply because all of the objects within our environment, they basically not in the same form. So for example, liquid or water, everything around you is not in that format in terms of liquid or water. So some things in our environment, they are in that format being liquid. Other things, they are being solid. And of course, we have things that are in the capacity in terms of the format of gas. So those are the three main state of matter. So there's no way everything in your environment could have been solid. If that was the case, then basically we wouldn't be able to drink anything that is watery or anything that is fluid, because everything is basically in that format which is solid. Now you will realize that if you want some water to drink, unless say, for example, all that is in the fridge is basically ice, then you would have to find a way to allow that ice to melt, because water can be in all different three states of matter. Water can be solid. It Now an example in terms of water being solid is whenever it is ice, whenever it is in that format in terms of ice. It is liquid or fluid whenever it is in that watery format. Now in terms of gas, persons can notice whenever they are cooking, and let's say for example you should open the pot, we see some things that is coming out that we call steam. Now, the scientific term for that is actually water vapor. Now, that vapor contain water, and that vapor is actually gas. Now, how you can prove or convince somebody that the vapor is water or it contain water, it is just that it is in that format which is gas. I don't know if persons would have noticed that whenever you remove the pot cover from that pot, you ever look underneath the bottom of the pot cover and you realize that you see some water there?
Yes, sir.
Right. Now that is the vape. Now once water vapor contact a surface, then that is when the gas will now convert and change over to a next format, which would be the liquid. So it is not because the water is bubbling up. Let's say, for example, some of the water splash on the bottom section of the pot cover. No, that is not how the water actually gets there. The water actually reach the pot covers in the format of gas. Because it is just that once something is vapor, for example, once the water is converted to vapor, meaning that it is a gas. Once that vapor touches a surface, that is when it actually start to form back into that fluid format in terms of that state of matter. So the second pointer, solids, liquid, and gases are all made up of microscopic particles. So what they're saying is that all the different format, all the different states of matter, they are made up of some tiny, small particles. Now, why they use the term microscopic is simple because they are so small that you cannot see those extremely small particles with your naked eyes. You would have to get the service of electronic microscope. That is how you would be able to see the smallest particles within a particular state of matter. So that is why they are saying that they are microscopic in terms of their size. The particles of each behave differently. Now we are talking about movement. Now you looking at the screen, there is a lot of movement that is taking place within that circle that looking at gas. Are you seeing that movement that is taking place?
No, sir.
All right. Yes, once you hear me explain and you're not seeing that on the screen, then you need to indicate to me and say that, sir, you're not seeing it. Because sometime for whatever reason Google Classroom seems to be not displaying what should be displaying. So you're seeing the screen now,
Yes, sir.
right?
Yes, sir. Yes, sir.
But I mean,
No,
you're not seeing the screen. You should be.
I'm seeing it.
Oh yeah,
I'm seeing it.
you're seeing the states of matter, right?
Yes, sir.
Right. So once I'm explaining, you need to follow the screen because everything I'm explaining, the notes already there in terms of the PowerPoint format. Right. I was looking at the second pointer where I said that where they said that solid, liquid, and gases, they are all made up of some microscopic particles. Now I'm saying the reason why they use that term in terms of microscopic is simply because the smallest unit that make up a particular matter, irrespective of whichever state you're looking at, that smallest particle that make up that state of matter, it is so small that you cannot see it with your naked eyes. That is why they say that it is microscopic. Now, looking at the third pointer, what it is now saying is that for all the three states of matter, in terms of how the small particles behave or react within the environment that it is in at that particular moment, they all react in different ways. And there's a particular reason for that. And the reason for that is the amount of space that is between each smaller particles. Now, looking at the screen, looking at solid versus gas, you will realize that you're seeing a lot of movement taking place as for gas. And that is simply because the particles that make up gas, they are much more further away from each other versus solid. Because I'm sure that if you look at a stone, for example, you have a stone in your hand. Now the stone is solid. That would be a solid state of matter. I'm sure that you looking at the stone, you cannot see the stone just moving by itself. But if you look at um, smoke moving, or if you should look at the water vapor moving, you realize that it is actually moving in the air. That is simple because the particles them normally bounce against each other randomly. But because there's a lot more space in gas, that is why you normally see gas moving and changing direction in the air. Have you ever light a fire and you actually see how the smoke just a move in different direction in the air?
Yes, sir.
Right. Now the reason why you're seeing so much movement, because the smoke would be an example of a gas, The reason why you're seeing so much movement is simply because the particles that make up the smoke in terms of that gas, they are really far apart in terms of their structural arrangement. Now, the only way the smoke can move is by those small particles just colliding or bouncing up against each other. So they basically change direction. I'm gonna give you a perfect scenario. If I should blindfold everybody, let's say for example a class of 30 students, and put you in a classroom, so I blindfold you all, and I put everybody to one corner, and then I should blow a whistle or say go and tell everybody to find their individual space. Now you in that scenario, I'm sure that you're gonna realize that your action once you start to move around, you'll start lick up in at each other. So once you lick up in somebody, you're gonna actually try to move to the left or try to move to the right because you want to find a space by yourself. So after a few minutes, I'm quite sure that you're all gonna spread out within that particular classroom after bouncing against each other. Now that's the same principle that take place in solids. Now the reason why I'm say again why the gas moves so fast is because the space is not that as tight as solid. So in terms of solid, there's a little bit of movement that is taking place, but it is not noticeable. And the reason why it is not noticeable is simply because the space is so compact. Now, in the middle now, that's where liquid fall. So liquid kind of have more movement than solid, but of course, less movement take place in liquid than gas. And if you have a bottle of water or a bottle with some juice, then you realize that you can move the bottle into different direction and you actually see the fluid or the water moving. Now the reason why you're seeing it moving so much is simply because again the amount of space within the particles. Now let's say for example that same bottle that contains the water, if you should now put that bottle in the refrigerator in the freezer and freeze it, I'm sure that when you take out that frozen bottle and you move the bottle in the same direction, you're not going to see that movement again. Me wrong or am I right?
Yeah, right.
Right. And
Right, sir.
right. And that is now simple because the state of matter now would have been changed from liquid to solid. And so now your common sense should tell you now when I ask that question and I'm on to test, because I'm going to ask you that question. Which state of matter the particles move most? And your answer for that question should be gas. Don't tell me solid, because that is totally wrong. So I will be formulating questions because a follow up to that question, I'm going to repeat the question. Which state of matter the particles move most? And the answer for that should be gas. And I can give you a follow up question for that and ask you why. So you now need to tell me or explain why the particles in gas move much more than the particles in solid. And the answer for that is simply because in gas, the space between each particles, they are much more further, they are much more distant. You have a lot more space between the particles in gas in comparison to solid. So have those question in mind in terms
Can
of
you please?
repeat.
Um,
No problem. You would be answering the question correctly, just that you use a different, I mean, concept in terms of how you explain. So that would be perfectly correct also.
Okay, sir.
Yeah. All right. So let's move on to the next slide. So what we'll be doing now, we're now gonna see if we can spend some time and study each state in much more detail. Now, gas always take the space and volume of a container. So that particular container that the gas would be in, it's gonna actually take the shape. It's gonna actually take the space. Fluid liquid is the same thing. Because if you should throw some water in a container, just like how the container shape, that's the same way the fluid or the liquid gonna actually stay. But as for solid, that is completely different. Because let's say, for example, you have some gravel, some stone, and you put those stone in a water bottle. I'm sure that when you fill up that bottle in terms of stone and you turn the bottle and you examine the bottle, you're gonna actually see some space where the stone basically not occupying. And that is simply because solid generally are solid don't take the shape of the container that it is being placed in. And that